whatever number. This can, you can use this random seed. Okay, so I'm going to use exactly the same. Okay, so this is, yeah, okay, so this is useful function that you can copy paste in the future. And this is actually working quite well. Okay, great, this is working fine. Okay, cool. All right, next exercise, finally. Are you guys okay?
Yes,
Hanging in
pretty
there?
good.
Okay, great. All right, so I'm going to copy this to start with. So I'm going to, just for now, copy, Control C, Control V, copy my starting points. I'm going to hide all of this. Brand new exercise. Okay. So I'm going to let these points to become my circle starting of my packing. So basically now what we are going to do is we are going to build this kind of exercise. So let me show you what we are going to do. So we have random points. We are going to now build this script so you can actually let them possess a radius. And what they're now doing is repelling each other to find their own space. So they're fighting with each other. And for him, he's trying to calculate every time and moving away from their clashing geometries around it. The downside of this one is if they're too far, they don't really go back. But that's fine. Like they're all kind of finding they calculate until they're happy with their packing. So they're calculating forever until they are finding their own space. So this is only be able to be done by all of these are calculating together. It's not somebody draw and tell them like you should be there or there. They are just repelling each other and fight for each other to find their own position. So that is the main main concept of object-oriented program that I was talking about before. Yeah. So that's what we are going to do. That's why we start from these random points that we just built. All right. So okay, we are going to build this. Yeah. So I need my. Okay. So let's start by C# script. Obviously, we need a reset button. So this will become our routine. We need to import our starting points. So I'm going to set start positions. We set as a Boolean. Start positions as list access and list of point 3D. Yeah, we only need that too. That's great. Okay, so to begin with, we are not going to let them have different radiuses. We are going to just let them have same radius all over. So it's a bit easier. So okay, so their starting radius, we need to set that. It's radius. We are going to set 6 as radius, which is around, because this is radius, so it's going to be around 6. So they will start from a very packed place and they will start to go away from each other. That's why it's okay to be quite big compared to their starting position. And say if reset is true or reset, you are going to declare a all centers list of point 3D called all centers is a new list of point 3D. And all centers is start position. And else we are going to let each of them to calculate so what they have to do is they have to compare with all of my neighbors first, yeah, and they're going to create they have to store a list of movement. So imagine, so for example, this as a reference. So imagine when I'm calculating this one, for example, I need to, in my frame, current frame, I need to consider first the calculation with this one and this one and this one and this one. And then as a result of total movement, I then calculate finally where I should go. So I don't calculate and move in the first goal. What I do is I calculate, I compare with my neighbor and compare and calculate a total amount of movement I need to go, and then I move myself. So it needs to calculate first and then move. So why do I say that? It's because you need to have, for each point, you need to have a vector to store all the movements before it actually moves. So let's see how it goes. So vector 3D. So total local moves is new list of vector 3D. So what this does is for each point or each circle, it stores a vector. So there will be same amount of total value, total moves vectors as the number of points. So if you have 100 points, you have hundreds of moves. And we also need a collision count. So how many, they are only calculating the count of their collision. If they don't collide with your neighbor, they don't count it. So you need that kind of number to be stored, collision count. And new, it's a list of double. Why double? Count can be integer, but because we are going to use this number to divide a number, so for division, you need to make it into a double. So you cannot make it as an integer. So we are going to go through all of these all centers. So for int I is 0, I is smaller than all centers count. So you're going through all these, and I'm going to make a temporal vector to store it here. So for now, I'm going to make an empty vector. So empty vector 3D. Temp move is a new vector 3D. This means it's a 0 vector. And then I'm going to add that to my auto moves. And then my collision count should start by 0. 0, 0. All right, so this is a preparation. So after you prepare, you want to go through each center. So you can copy this. And that's actual calculation happening. So for each point, I have to loop this entire thing again, but changing the value to j. And what I'm going to do with this loop is that I'm testing and counting my distance with my neighbor. So double distance is all my centers I, distance 2, all my centers j. And where is distance 2 coming from? It's coming from the documentation. So it's coming from the point 3D documentation. So structure, so there is distance 2. So that's what we are using. So we are testing from myself to my neighbor and checking the distance. And if the distance is smaller than my radius, then it means I'm colliding, right? So if the distance is smaller than twice of the radius, or my radius plus my neighbor's radius, right? So in the future, if you have different radiuses, you should have my radius plus my neighbor's radius, for example. But now you can just say radius plus radius. And vector 3D, I calculate a local movement. This is per one, towards one neighbor of myself. So local move is all centers I minus all centers j. And local move unitize. So you are unitizing it first before you actually scaling that to a certain number. So I'll explain you what this is doing. So first is times radius plus radius and divide minus distance. And so what I'm doing now is I'm calculating if I have me, let's say, copy. I have me and I have my neighbor colliding with me. And its center is here and here, right? So I have to, if I have a collision, I have to go like that, isn't it? In my next frame, because I need to avoid this guy, right? So this entire 3 line is calculating this vector. So what it's doing is I'm making a vector firstly like this. See, from center of me to center minus center of my neighbor. And then I unitize it by making this scaled 1 scale. So this scale to be like 1. And then scale this to a proper scale, let's say, according to their distance relationship. And that is my local total value. So that's what I'm calculating. And this value is where I should be. So where should I be? So I should be here. I should be literally here, right? So I only need to go how much? This amount, right? So this is actually a way of calculating that vector. And why do I making it to half? What I'm actually doing is I'm adding the half of my movement to myself. I divide this half and I make half scale half. I let me to move half and I will add the other half to my neighbor. And that's what I'm going to do in my next line. So that's the whole calculation. So this local move is actually a calculation of this thing. So how do I add that move to myself and my neighbor? So say total moves I is my movement, determines my move, right? So I add this local move to myself and I minus that to my neighbor's local total move. And my collision count will refresh, becomes 1. My neighbor's collision count also increase by 1. J. Yeah. So be careful, this is minus, but this is plus. Okay. So once everything is calculated, so why do we need this local move? Because, so I made the decision and I have my vector considering this neighbor. Great. But in case I will have a lot of neighbors, right? So with this neighbor, I will get a vector like this. With this neighbor, I will get a vector like that. So the last vector to determine my movement should be a addition of this and as an average. That's why we need to add all of these and divide by this count and then add that to our position. So we are going to finally go through all of our points. And only if my collision is not 0, or you can say this is not 0. You can say also bigger than 0. Because if collision is 0, it means I don't have any collision. You don't need to calculate, right? But also it's going to error because division doesn't work for collision. So my point should be refreshed by the total moves now and divide by total collision. And at the end, the end. So let's see this. So else, be careful with the location. Okay, so else at the end, A is all centers. Okay, something is erroring. Let's check. Ooh, lot of errors. Okay, go through one by one. So line 64, list of vector 3D is new. List. And line 69 can be add. Or timer. All right, so it's actually working. Okay, so to visualize this, because we have radius as 6, so we can also have this as an input. Wait, oh, sorry. 6.0. This should be my radius. Control C, Control V, double, delete this line. So you can make a circle to display, circle C and R, which means center and normal and the radius. Cool. So you can see that they are looking for their position. Yeah? Great. So what's the time? How long do we have? 1 more hour?
Yeah, we can have 1 hour.
Okay. How is it going so far, guys? Following? Okay, very quiet. Okay. Yes, I can share. Okay. So this is doing. Just wondering. Okay, at least it's working. Just let me add just one more thing by changing their radiuses to random. For that, we can also modify this a little bit, or we can have it here. Let's modify this. So C#, creating random numbers. And we are going to make this many random numbers with this many, this random seed. This random seed can be whatever. And this is the count. integer. This is a integer random seed. Can you add another expression to control the range it goes? So it stops when radius 2 is distant. Well, yeah, but it shouldn't stop in theory because they have to continuously calculate. Yeah, but there's something wrong with this one. Yeah, because they're going too far, isn't it? Yeah, but let's see if I can fix that. But I'm going to share with you this version anyways. Yeah, so this version has slightly more upgraded and compacted as a class. So if I have time today, I will just explain you a bit of the structure of the class so you understand the structure, and then you can then understand this one. It's not much lines here. So this one you don't need to show. But anyways, I will share this one that is working code. Yeah, but this one, at least it's kind of finding their own position, so it's not too bad. This one, I'm just trying to make this random radiuses, yeah? So random is new, random. A is my, no. So it should be a list of integer, list of integer of all values. New. All value is 4, int I is 0, I smaller than count, I plus plus, all value add my random dot next. Seed. See what's the error message? Random. 61. Value add some invalid argument lines. Oh, because this is not integer, it's double. Oh, so it creates a lot of numbers random, and you can have them in a range of from, let's have that range also as an input. So 0 to 6, let's say 0 to 7, 10, 8. Minimum value, let's also give a minimum 2. I'm going to give a minimum value